All right, we're talking about L'Hopital's rule today, which is a way that we find limits. It's actually using the derivative to find limits, which is actually really cool. I know every time I say something is cool in calculus, you guys are like, yeah, okay, your definition of cool, but it is cool. All right, so basically the idea is L'Hopital's rule, we use it when we have one of two indeterminate forms. So our indeterminate forms are 0 over 0 or infinity over infinity, which basically is stuff we can't do, right? There's no such thing as 0 over 0 because we can't divide by 0. And infinity over infinity, we really don't know, like, how big of an infinity, like a little infinity or a big infinity. You know, there really is no such thing. So L'Hopital's rule helps us whenever we find with direct substitution that we have the indeterminate form. Now, one thing that I want you to think about and to pay attention to is I never, ever, 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 ever want you to see you write on your paper equals 0 over 0, okay? Because the limit does not equal 0 over 0. It can't equal 0 over 0. That doesn't exist. It's not something that it can equal, so we are not going to write equals 0 over 0, or we are not going to write equals infinity over infinity, okay? Those are never going to be written on your paper. You might think them in your brain, but you're not going to write them on your paper, okay? Because it's just not a notation that makes sense, okay? Because 0 over 0 doesn't exist. Okay, so this is what L'Hopital's rule says. If, when we find the limit of this function, we get the indeterminate form 0 over 0 or infinity over infinity, the limit of that function equals the limit of a function that has the derivatives. So like the limit of f of x over g of x equals the limit of f prime of x over g prime of x. Okay? So then we use L'Hopital's rule to find that limit. Okay, so let's see what it actually looks like. So here we have our first limit. If we plugged in infinity, and again, we're going to think it in our heads, not write it on our papers, okay? If we think this equals infinity over e to the infinity, which is, again, infinity, so this equals infinity over infinity, that's an indeterminate form. So I'm going to apply L'Hopital's rule. So we have equals, and the limit of this equals the limit, as x approaches infinity, of the derivative of the top, which is 1, over the derivative of the bottom, which is e to the x. And I'm going to make this notation that I use L'Hopital's rule. It's just spelled like hospital. It's just not said like hospital. Okay, so by L'Hopital's rule, the limit of this function also equals the limit of this other function, which is the derivative over the derivative. Okay, so don't forget the limit notation there because super important. A lot of times people just write equals and then this function. The limit of this does not equal that function. The limit of this equals the limit of this function. Okay? So by direct substitution now, what is the limit of the function? So we remember when we find the limit, we put infinity back in and we get 1 over e to the infinity, which is a huge number, right? Well, what is 1 over a huge number? It equals 0, right? Because 1 divided by any huge number is just going to eventually be 0. So this limit is 0. All right, here's this one. The limit is x approaches infinity. Again, we're going to think it in our heads. What happens when I put infinity into this? I get infinity over infinity. So, by L'Hopital's rule, I'm going to say that I'm using L'Hopital's rule here. This limit also equals the limit as x approaches infinity of the derivative of the top, which is e to the x, over the derivative of the bottom, which is 1. And so now we try direct substitution again, and we say, okay, when we plug in infinity, what do we get? We get a huge number over 1, which is still a huge number. So that is infinity. Or it does not exist. We could call it either one, because truly infinity is not a limit, because a limit means something is limited, and infinity is not limited, right? Infinity is unbounded. So it could be, you would write infinity or does not exist. Okay, number 3. Again, in our heads, we're going to think, if I direct substitution this, if I put 0 in for x, I get 0 over 1. What? I get 0 over 1, not 0 over 0. That's not an indeterminate form. 0 over 1 is just 0, right? 0 divided by anything is just 0. So this one does not need L'Hopital's rule. So this is a really important one to think about. Just because it looks like you should use L'Hopital's doesn't mean you do use L'Hopital's. It absolutely has to come out when you try direct substitution. It has to come out 0 over 0 or infinity over infinity or negative infinity over positive infinity, any form of infinity over infinity. It has to come out with one of those two forms. If it comes 0 over 1 or just anything else super nasty that you're like, I don't know how to do that, it's still not a candidate for L'Hopital's. You only use it when you get 0 over 0 or infinity over infinity. Okay. So what about this one? We plug in 0, we get 1 over 0. Okay, so this is a problem because we're dividing by 0. But it actually is only asking for it as we're approaching from the left side, from the negative side, right? And what's going on there? Well, these numbers aren't actually 0. They're like 0.000000001. They're negative 0.000 whatever. So what happens when I divide 1 by a tiny, tiny, tiny negative number? I get a huge negative number out, right? 1 divided by a tiny number is a huge number. Okay, so the limit of this one is negative infinity. Again, I did not need L'Hopital's for this because I did not end up with the indeterminate form. I do not have 0 over 0 through direct substitution, so I do not use L'Hopital's. I just have to then reason about the fact that it's coming from the left. Okay. Now this one, the limit as x approaches 0, so we plug in 0 and we would get 3 minus 3, because that'd be e to the 0, which is 1. 3 minus 3, so that is 0 over 0. So this is an indeterminate form because when I use direct substitution, I get 3 minus 3, which is 0, over 0. Okay, so I can use L'Hopital's rule here. Okay, so by L'Hopital's rule, I know that this limit is equal to the limit as x approaches 0 of the derivative of the top, which is negative 9 e to the 3x, because I used the chain rule, over 1. What is the limit? What is this limit? Well, again, we try direct substitution. We put 0 in, and we get negative 9 times 1 over 1, which is negative 9. Okay, so here's one more plug for do not use L'Hopital's rule just because it looks like you should use L'Hopital's rule, okay? You only use L'Hopital's rule when you get the indeterminate forms of 0 over 0 or infinity over infinity. Okay, now here's the super cool thing about L'Hopital's rule is that you can use it again and again, okay? So when you get the indeterminate form by using direct substitution, you get 0 over 0, you're like, okay, I'm going to use L'Hopital's, and then you get this new limit, and then you use direct substitution again, and you get out 0 over 0 again. Guess what? You can use L'Hopital's again. In fact, I think it was in Calc 2, we sometimes used L'Hopital's like 3 or 4 times before it came up with a valid, like a limit we could actually evaluate. Up until then, it was just like kept indeterminate, indeterminate, indeterminate. So we have to check by direct substitution to make sure that we are still getting an indeterminate form. Because sometimes what will happen is you get like indeterminate, the first time you get 0 over 0, then you take the L'Hopital's rule and you get 0 over 1. That's not indeterminate, so we don't use L'Hopital's again, okay? All right, so this one, the limit as x approaches negative infinity, so we think in our brains, when I put in a big number on top, I get a big number. When I put in a big number on bottom, I get a big number, right? So this is a big number over a big number, that's infinity over infinity. Okay, so this is a candidate for L'Hopital's, so I'm going to apply L'Hopital's. I'm going to apply L'Hopital's rule, so that limit equals this new limit, right? The limit of that function equals the limit of this function, which is just the derivative of the top over the derivative of the bottom. And I use the chain rule to find that the derivative of the bottom is negative e to the negative x. Okay, now I use direct substitution again, and I put a big number in the top, and I get a big number. And I put a big number in the bottom, and I get a big number. So I still have an indeterminate form. I still have infinity over infinity. So I can use L'Hopital's. In fact, I have to use L'Hopital's again. So by L'Hopital's, the limit of this function equals the limit of this function, which also equals the limit of this new function I'm going to write. The limit of, as x approaches negative infinity, of the derivative of the top over the derivative of the bottom, which goes back to e to the negative x, because the chain rule gives me two negatives. Okay, and then I look at this, and I try direct substitution again, and I put negative infinity into it, and that means it's 2 over a huge number, and 2 over a huge number is going to be 0. So the limit of this first function is 0. Okay, last but not least, here's this one. And you like freak out a little bit because you see the ln in there, and you think you're going to have to do something really hard, and it's not. Okay, so the first thing we do is direct substitution. Well, ln of 1 is 0, minus 1 plus 1, 1 minus 2 plus 1. So that becomes the indeterminate form 0 over 0, right? Because negative 1 plus 1 is 0. Yeah, so it's 0 over 0. So by L'Hopital's rule, I can just take this limit equals the limit as x approaches 1. And now I can just take the derivative of the top. And remember, these are each individual term, so I just take the derivative of each one. So the derivative of ln x is 1 over x. Derivative of x is just 1. And the derivative of the bottom is 2x minus 2. Okay, now I check. If I put 1 in here, what happens? I get 1 minus 1 on top, which is 0, so I'm not looking good, and then 2 minus 2 on bottom, which is 0. So I get the indeterminate form of 0 over 0 again. So I can apply L'Hopital's rule again. And I get that that limit of that function equals the limit of this function. The limit as x approaches 1 of, and I take the derivative of the top. Well, the derivative of x to the negative 1 is negative x to the negative 2. So it's negative 1 over x squared. Derivative of 1 is 0, and the derivative of that bottom is 2. So now I've tried direct substitution again, and I plug 1 into this, and I think, okay, that equals negative 1 on top. Oh, this is good, not a 0. And it equals 2 on bottom. So the limit as this approaches 1 is negative 1/2 by direct substitution. And that's it. That's L'Hopital's rule in a whole. It's like actually kind of cool and beautiful. So I hope you liked it.